Good day, everyone. Welcome to an episode of Chemistry Made Easy with Fumbi. Today we'll be running through an introductory class of chemistry, what it is, the branches of chemistry, and the uses of chemistry. I know many of us are quite familiar with what chemistry is, so we'll just revise together again. Chemistry is a branch of science that deals with the study of matter, its structure, composition, properties, and the changes it undergoes. It involves the study of material substances that occur on Earth and in the universe. Chemistry, as we all know, is a relevant and developing science which is making essential contributions towards human life, society, industry, and civilization. We all know that the basics of most products that we use, our day-to-day products, our food items, are chemicals. And these chemicals all have their structures, they have their characteristics, they are all made of atoms. So chemistry is a very relevant subject and very interesting also. So we move on to the branches of chemistry. The branches of chemistry, broadly speaking, should have been just physical, inorganic and organic. But of course, we have analytical chemistry and biochemistry. And also, broadly speaking, you can divide chemistry into two parts, the theoretical part and the practical. And a good chemist must know that analysis is a must because you carry out a lot of research in chemistry. So let's talk about physical chemistry. Physical chemistry, there are topics like nature of matter, separation technique, particulate nature of matter, atomic structure, kinetic theory of matter, the periodic table, chemical combination, chemical formula and equations, the mole concepts, types of chemical reactions, air, water, energy, rates of chemical reactions, chemical equilibrium, electrolysis, redox reactions, shapes of molecules. I'm sure these are some of the topics we've heard already, or you have been taught already, and these are the basics. These are the things that shows us what periodic table is, the chemical formulas, atomic number, periodicity. This is all under physical chemistry. We move on to inorganic chemistry. Inorganic chemistry, we have topics like hydrogen, hydrides, of course, oxygen oxides, hydroxides, carbon and its oxides, and fuels, nitrogen and its compounds, sulfur and its compounds, the halogens, chlorine, fluorine, bromine, all those elements and their compounds, metals and their compounds, qualitative inorganic analysis, all that are under inorganic chemistry. You know, organic chemistry on the other way are carbon compounds, any carbon compound rich in carbon. We'll be talking about organic compounds here, hydrocarbons, petroleum, crude oil, hydroxy compounds, those are like alkanols, alkanals, alkanones, alkanoic acids, alkanoids, esters, fats and oil, organic compounds of nitrogen, the carbohydrates, and of course qualitative organic analysis under organic chemistry. This organic chemistry is a wide and very voluminous aspect of chemistry, and it's quite interesting, very interesting. We move on to biochemistry. Biochemistry is the study of chemistry of living things, and here we'll be talking of topics like industrial raw materials, chemical industries, biotechnology, medical biochemistry, pharmaceutical biochemistry, plant biochemistry, environmental biochemistry, forensics, genetic engineering, etc. Most preliminary schools like high schools, secondary schools, they deal with this in bits until when you go into the university and go further. We'll talk now on analytical chemistry. All chemists must be good analysts because analysis is the basis of most of the discoveries in science. we have the qualitative analysis and the quantitative analysis. The qualitative analysis deals with species, what makes up a particular substance, knowing what kind of elements, what kind of cations, anions are in a particular compound. While the quantitative analysis deals with titration, anything that goes with volumes, measurements, and the likes. So we start with qualitative analysis. The first part is qualitative inorganic analysis. And here we will talk of acids, bases, and salts, because we'll be checking on acids, bases, and salts. These are the three range of compounds. Then we start with what the first one is: identification of cations. We have cations, we have anions, and we have gases in any compound, be it an acid, be it a base, be it a salt. And for the cations, the tests that you carry out are appearance of solid, flame test, that's you apply flame on the dry substances, action of heat on the solid sample, test for cations in aqueous solutions, that's now a wet test. There's a dry test and there's a wet test. Here you can use reagents like sodium hydroxide, ammonia for the test. Then there's test using hydrogen sulfide gas, test using hydrochloric acid, test using concentrated acid, HNO3, and other additional confirmatory tests for these ones. The second aspect is identification of anions. We've just seen what cations, the test we carry out on anions, on cations. Now we move to anions. Note that anions of salt can be volatile weak acids, they can be strong acids, and they can be non-volatile strong acids. All this will be explained with time. Test for volatile products, that's the dry test, action of heat, action of diluted HCl on solid sample, action of concentrated H2SO4 on solid sample. Test for radicals, the wet test. You use reagents like silver triosonitrate 5 solution, barium chloride, lead-2 ethanoate solution, magnesium tetraoxosulfate 6, phenolphthalein indicator, acidified potassium tetraoxomanganate 7 solution, KMNO4, use of iron 3 chloride solution, all those ones for wet test. Then there are additional confirmatory tests for halides, for SO3 2 minus, for SO4 2 minus, for NO3 minus, NO2 minus, CO3 2 minus, HCO3 minus. All those are cations that can be tested individually. Then the third one is identification of gases. I said there will be cations, anions, and gases, because these are the things you can get in any compound. Most compounds have the cation, the metal part, the non-metal part, and some of them have gases that are produced. So the first one is by color recognition, by odor detection, by use of litmus papers, confirmatory test for CO2, SO2, H2SO4, NO2, HCl, Cl2, ammonia gas, hydrogen gas, oxygen gas, and water vapor gas. So we move to the second part of analysis, which is the quantitative analysis. We've talked about qualitative analysis. Here we have three major types of titrations and reactions. The first is acid-base titration, which is the common one that we get in most WAEC questions. Then the second one is redox reactions, that's reduction, oxidation, titrations, and the third one, precipitation reactions. This all goes with measurements and volumes and measurements basically. Now you will realize that if you are familiar with WAEC standard, a qualitative question is asked, a quantitative question is asked, and general test of the knowledge of chemistry, which is the third question in WAEC questions, practicals. So all these are things you should be familiar with. We will be taking some of these as much as we can cover as the weeks go by. Thank you very much. Let me know what you want me to teach, and we can always look into it. Thank you very much. Have a blessed day.